Αυτό το slot θα του έβαζα ένα τίτλο «Το Internet Exchange Slot». Μεγάλο ενδιαφέρον από Internet Exchanges και καινούργια Internet Exchanges στη χώρα. Καλώς εχόντων των πραγμάτων θα ακούσουμε πολλές και διαφορετικές παρουσιάσεις. Και ξεκινάμε με το Free Internet Exchange. So, to accommodate the English-speaking audience, now it's our Internet Exchange slot. We start with the first presentation about the Free Internet Exchange by Antonis Chariton. Γεια σου, Αντώνη.
Okay, thank you. I didn't expect to see an IXP session at GRNOG anytime soon, so that's a first. And I'm going to talk about FreeIX Greece. First of all, I have to tell you what this is. Well, first of all, it's free, which means that people don't pay. It's something that you have no recurring costs for, you don't have any setup fees. Then it is an internet exchange, so people really just exchange traffic. ISPs connect to this network, and then they can exchange all of the data they need. And the final important point is that it is in Greece. So the name is really self-explanatory. I don't have to tell you too much about it. But on a serious note, let's see what this is. It is a physical IXP that we have. It is in Thessaloniki and Athens. It has a single peering LAN between the two cities, so it's unified. And it has no setup or recurring fees, as I said earlier. So anyone can connect there with 10 gigabits, 25 gigabits. There is no cost for that. And it is a service that we are running non-profit, like we volunteer our time and everything you see here. And the reason we do this is that we want to help this country. We have the same model in a few other countries in Europe. And the goal is to help improve connectivity locally in the places that we are running this service. We are currently in two locations, in Balkan Gate 1 in Thessaloniki and TI Sparkle 1 and 2 here in Athens. And thanks to some sponsorships, we are able to move to two new locations in Digital Realty in Athens and Heraklion, and we are waiting on the connectivity part for now that we hope we're going to resolve soon. And with that, we hopefully have decent coverage in the country. We were hoping to be the first IXP in Crete. Unfortunately, we can try to be the first IXP in Heraklion, which is good enough. Yeah, we're narrowing it down as we go. And just some statistics, it's still like less than a year old. So we have 10 members right now, around 2 gigabits of traffic, and it's just 2 switches. So it's very simple. And the purpose of the talk today is not to announce this, like you can go find the website, you can connect to it, this is fine. But I wanted to give you a technical presentation on the infrastructure behind it, what it costs, what it takes to run it, and some problems we had along the way. So first of all, I mentioned we have 2 switches. They are Cisco Nexus switches, this particular model here. And they have 48 25 gigabit ports where the members connect. They run NXOS, the latest version available, and these are the cloud switches that Cisco is providing, and they cost, you can find them for 500 euros or 10,000 or 20,000 euros, depending on how much you want to pay. It's up to you. And then we have 2 servers, 2 Dell R640s, where we run all of the services like IXP Manager. This is the platform that we use for members to see their ports and provision services and so on. The route servers to exchange the traffic, we use BERT2, and we have added some additional communities, like some members, especially in IXPs in multiple cities, some people may want to learn which routes originate from that city, which originate from another city, and then filter based on that. And we run some DNS servers, metrics, and all of that. And the servers, the way we have them configured, you can find them for 800 euros or 5 to 10,000 euros each. And depends on how much you want to pay, really. So the whole IXP is basically 4 rack units, 2 plus 2. And this is the whole footprint that we have. The connectivity, we have 200 gig connections between the two cities. And we use IP as the underlay for that with OSPF and TCMP to balance the traffic between both links. And the peering LAN, we implemented with EVPN VXLAN. And basically we have everything running on top of EVPN like many IXPs do these days. And we use all of the features like ARP suppression and all of that to eliminate unwanted traffic. And because one member in this GRNOG cares about that, we have a 1500 byte MTU that is fixed for all customers. We had a presentation about that a few GRNOGs ago. So this started a little bit over a year ago. And I told a few friends that we are trying to build this, and this is something that will help. And they all had one question that they came to me with. Like, why are you building an IXP on Cisco? Why like Cisco switches? And it's a bit funny because like a few months later I started working at Cisco. I'm still working there, but all of that is personal work that I do outside of the company. It's not related to my day job. And everyone was telling me that most IXPs run on other platforms. Cisco doesn't have dedicated products for IXPs. But we thought, okay, like let's try that. Let's gain the experience. Let's see what works and what doesn't. And just take it from there. And if we cannot make it work on Cisco before we onboard members, we're just going to try to use another vendor if possible. So we ran into problems, as it's naturally expected. Licensing, I'm not going to talk about that. Hopefully you know about this part. But I'm going to focus on the other things we had, like the software issues, the hardware issues, and some kind of vendor-specific issues that we had setting up the platform and operating it. So let's begin with the software. NXOS, we need to do BGP because we have the EVPN mesh. And let's say it's not iOS XR. Like BGP on NXOS is interesting. There are some options, some configuration options we had issues with. We ran into bugs. We spoke with other people that had bugs in NXOS BGP as well. And we had to add additional configuration that was normally not needed to make this thing work. Eventually, it was nothing we couldn't overcome. The other issue we had was the lack of tooling. When we had to troubleshoot something, at least the operating system didn't give us deep enough access or enough logs to know whether it's some kind of bug, whether it's some misconfiguration. We had to really try to learn how to troubleshoot EVPN before onboarding any actual members, before having any traffic on the exchange. And we had to really study the internals of these switches to get the understanding. And then the other thing is that Cisco sells this as cloud switches. They don't sell them as layer 2 switches. And this is by design. This is the market they aim for. They want to target that segment. And we were kind of misusing the switch in reality, but this was close enough to what an IXP could run that we wanted to try with this particular model. And these were the software issues. Now, in terms of hardware, this is where things got really interesting and where the misuse became more apparent. First of all, there are some things that IXPs typically have. There is this thing called BCP 214, where what happens is that if you want to perform some maintenance on the exchange, first you want to kill all of the BGP sessions that are running on top of the exchange between the members, and then the traffic eventually slowly drains and you have the traffic flowing through other IXPs. And then you do the maintenance, you remove this list, and then this ACL, and then traffic starts flowing again because BGP sessions are re-established. And this is a smooth way of taking the IXP down if not every member is taking action on their own network. The problem we discovered is that this is a hardware limitations. Our switches could not physically, in the ASIC, do certain functions required for this to work. And because it's a hardware limitation, they never will. Unless we change the switches, we could not work around that. We found a way that blocks any type of BGP session on top of the exchange, but not just the peering LAN, which is an intermediate solution that, okay, can help us move forward. The other thing we faced was the TCAM space. And for those not familiar with it, every switch, because they have to move a lot of traffic, they have very small amounts of memory, let's say 10 megabytes, on the switch chip that's used for certain things, like the routing table, the MAC table, ACLs, all of that. And up to a decade ago, a little bit more maybe, vendors started allowing you to configure this however you want. So you could say, I don't have too many routes, leave 1 megabyte for the routing table, and I have a lot of ACLs. I want to use a lot of that space for ACLs. And that's called TCAM carving specifically. However, that means you need to predict the future ahead of time. You need to predict what features you're going to need on the switch, and you're going to have to set it up ahead of time, because if you ever want to change this, this is a disruptive change. It will take down at least the switch, if not more in some cases. In our case, because the space was so limited, we had to pick between, we needed the ACLs, for the BCP214 that I mentioned earlier. So we had to drop things like QoS or other things that we may want to do in the future. And this was another problem that we had to make. It was a trade-off, and we had to pick what we wanted to run with and what we think is going to be more valuable for the exchange, until at least we can replace our switches maybe in 5 years or whenever they go out of end of life or end of security updates at least. The other hardware thing we had was something that a lot of IXPs do, where they support reseller ports. So you have someone, they plug in a physical port, a 100 gig port, let's say, and then they get access to it themselves through a VLAN on that port. And then you have other members that are tagged as VLANs, and they are moved transparently into the same internal peering LAN on the exchange. This is called remapping. There are many names for this, but basically you tag VLANs 100 through 110 on a physical port, and then internally you convert them into a single VLAN that you're using for every member. We don't have resellers because we don't sell anything, but in theory it could prevent us from having them in the future. The thing is that this feature works, so the switch is supported, but after going through Cisco documentation extensively, we found that could not apply ACLs in these ports, which means that if you're a reseller and any one of your members does something bad, the only option we have as an IXP is take down the whole physical port, or just leave it happening and let the reseller solve it, which is not great. We wanted to have this fine-grained options to set ACLs, port security, all of these features that we need to protect the fabric from our members if there is a misconfiguration. And this is the reason why we need a physical port per member, and we cannot support multiple members on the same port. We can do this, but we don't feel confident providing enough security and reliability to the platform and to the members, and protecting them against themselves, basically. And the final thing, the final issue, was the vendor-specific stuff that we had. So EVPN, for those that don't know, it uses BGP to convey MAC addresses instead of IP addresses, like on the internet. we transfer MAC addresses and kind of VLAN IDs, the VNIs. So it has some special communities like the targets and the distinguishers, and there are some certain ways to set them. You can hard code them if you want. But NXOS, if you read the documentation, it said, yeah, leave it up to us, we'll take care of it, and you don't have to worry, we will manage it, as long as you only use Nexus switches, of course. And the issue with that is that if you ever want to add another switch, let's say if you want to add a reseller switch that can do these features that we cannot do today, we would have to basically recreate the entire IXP from scratch. We would have to tear down the EVPN and set it up using some sort of standard that works across vendors. So we had to deviate from the official documentation, and this required studying. There were not too many examples online on how to do this, what's the proper way of configuring it, and it took us some time to figure it out, but eventually it ended up working. We had other vendor-specific issues, but this was the major one, because this means if we ever introduce another vendor, we'll have to set up everything again. So, as a final question, is this a bad thing? Like, did we do a bad job? What happened? Well, its product is designed for a specific market. So I don't blame Cisco in this case, because they designed a cloud switch and we are using it for an IXP. There are other vendors that design specific IXP switches. We just didn't get it. It was too easy, right? And we tried to do engineering to work around the limitations, either financial or physical limitations of the hardware we had at hand. And we think that the solutions we found are a good trade-off that can provide a long-term stability to the platform. It's been running for around a year with no issues so far. And we feel confident that we can add the new POPs, like the new digital realty data centers, without causing any downtime. We can also upgrade the switches without taking everything down and causing traffic loss. And eventually we were able to work through most of these issues as well. So the point I wanted to make is that even if the vendor does not offer it, maybe if you spend the time to engineer your solution, you can work around these limitations. And that's all I had for today. Thank you.
Any questions for Antonis? Ερωτήσεις για τον Αντώνη? Το μόνο που έχω να πω εγώ είναι πολύ ωραίο μπλουζάκι.
Ευχαριστώ.
Θανάσης Ζωήτσης. Αυτό που είπες για τα RD και τα route distinguishers and route targets είναι interoperable. Το NXOS είναι interoperable. Μπορεί να φτιάξεις, ας πούμε, μια τοπολογία με NXOS και αρίσταθο, για παράδειγμα, ή NXOS και Sonic, για παράδειγμα. Απλά πρέπει να τα βάλεις όλα χεράτα. Δηλαδή, αν πεις θα αφήσω να φτιάξει μόνος του, θα μπερδευτούν μεταξύ τους. Αν τα βάλεις όλα χειροκίνητα, είναι επιβεβαιωμένο ότι δουλεύει.
Σωστά. Απλά είναι κάτι που πρέπει να φτιάξεις από την αρχή και να ξέρεις ότι χρειάζεται. Γιατί αν ξεκινήσεις και πεις έχω μόνο Cisco και το στήσεις σε Cisco και χρειαστεί μετά πρέπει να το ξαναφτιάξεις όλο από την αρχή. Οπότε αυτό ήταν το πρόβλημά μας. Δεν μας το είπε κανένας και έπρεπε να το μάθουμε μόνοι μας. Ευτυχώς πριν μπουν μέλη και πριν έχουμε κίνηση.
Ευχαριστώ πολύ.
Εγώ ευχαριστώ.
Άλλες.
Τα μέλη πώς πάνε είναι η ερώτηση. Έχουμε αυτή τη στιγμή 10 και προσπαθούμε, ελπίζουμε εδώ πέρα να βρούμε και άλλα μέλη. Έχουμε ακούσει ότι υπάρχουν χρήστες με ES σε αυτό το δωμάτιο, οπότε οποιοδήποτε θέλει να συνδεθεί μπορεί να μας στείλει ένα email ή να μπει στην ιστοσελίδα freepavlaix.gr, να κάνει αίτηση και μετά του δίνουμε το έγγραφο για το Cross Connect και αυτό είναι. Εμείς δεν χρεώνουμε κάτι. Ναι, παρακαλώ.
Hi, this is Otto. I work for Vodafone. I run the global peering policy for Vodafone. Because it's free, I am assuming it's a best effort service obligation you give to your customers. Is that right? So isn't that a problem for the larger, let's say, infrastructure providers if there is no service obligation?
So yes, it is a service that we are running as a best effort, right? We don't have any SLAs because we don't charge for it. And the thing is, when we started, at least here, there was one IXP, really, and there was no alternative path. If this IXP has maintenance, which is perfectly normal, or downtime or whatever, there was no alternative. And we felt that even a best effort option is much better than sending the traffic through transit. So we wanted to offer just a second option for local networks, and this is why we started. Now there are 5 IXPs, so I guess there are more options. But we don't recommend anyone drop, GRX or any other IXP. We want them to have a port there. We just make it, the cost of a cross-connect to connect to us as well, so you have additional paths, and that's it. We offer additional paths through a different design, different topology, and hopefully it will be good enough.
Άλλες ερωτήσεις? Any other questions? We still have, or we are over time. Thank you, Antonis. Ευχαριστούμε.